Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, subject code CS3452, Theory of Computation, Unit 3, topic Languages of Pushdown Automata, objectives to understand the languages accepted by pushdown automata, to analyze the problems to check for the acceptability for their language. Languages of pushdown automata, it can be accepted by pushdown automata using two approaches, acceptance by final state, acceptance by empty stack. First, we are going to see acceptance by final state. It is said to accept its input by the final state if it enters any final state in 0 or more moves after reading the entire input. Here also we are going to use the 7 tuples of pushdown automata. Then only you can able to find out the given language is acceptable by the final state. It can be defined by L of pushdown automata equal to WQ0, W, Z, that tends to Q, epsilon, epsilon. Here the Q0 is represent the start state, W is represent the input string, Z is already available in your stack. Epsilon means once you finish everything, your stack is empty. Next, you are going to see acceptance by empty stack. On reading the input string from the initial configuration of for more pushdown automata, the stack of pushdown automata gets empty. So the language acceptable empty stack, it can be defined as the n of pd equal to w q0 w z, that is belongs to q epsilon epsilon q is belongs to q. Equivalence of acceptance by final state and empty stack means if L equal to n of p1 for some pushdown automata p1, then there is a pushdown automata p2 such that L equal to L of p2. Next, we are going to see one example for the pushdown automata. Construct a pushdown automata that accepts the language L over 0, 1 by empty stack, which accepts all the string of zeros and ones in which a number of zeros are twice of number of ones. So now go in solution. There are two parts of designing this pushdown automata. That means why we are going for the two parts means in the given question the given string is 0 and 1. So if 1 comes before any zeros, if 0 comes before any ones. So we are going to design the first part, 1 comes before 0. From the logic you are going to read single 1 and push 2 ones onto the stack. Therefore on reading 2 zeros, pop 2 ones from the stack. Now we are going to write the transition function for that zeros and ones. Do of q0, 1, z equal to q0, 1, 1 z. That means here z represents the stack is empty. Do of q0, 0, 1 equal to q0, epsilon. That means the second part, if 0 comes before 1 means it is the read first 0, push it onto the stack and changes the state from q0 to q1. Likewise, if 1 is encountered, then pop 0 being in q1. If q0 is read, then simply read that second 0 and move ahead. For that, transition function is do of q0, 0, z equal to q1, 0 z. Do of q1, 0, 0 equal to q1, 0. Do of q1, 0, z equal to q0, epsilon. That means it indicates that 1 and 1 is already read. So simply read the second one. Do of q1, 1, 0 equal to q1, epsilon. Now we are going to write the entire pushdown automata for the given language L is do of q0, 1, z equal to q0, 1, 1 z. Do of q0, 0, 1 equal to q1, epsilon. Do of q0, 0, z equal to q1, 0 z. Do of q1, 0, 0 equal to q1, 0. At last, if each and every input read, it will pop out. At last you will get the empty string. So the given grammar for the pushdown automata is the accept state. Thank you.